welcome back to AI. Let's talk about it. Normally, I like to say hello personally and to greet you. Unfortunately, I was a little clumsy this week and I tripped and knocked over my monitor and camera. And so this week, you're not going to have the pleasure of seeing my smiling face welcoming you to AI. Let's talk about it. But I still wanted to try and get a video out. And so today I want to talk to you about understanding and addressing bias in artificial intelligence. As artificial intelligence and other emerging technologies become increasingly integrated into our daily lives, it's essential to recognize and address the biases that can influence their outcomes. While often discussed, bias in AI extends beyond the data used for training models. It also involves how terms are defined, how information is classified, and even what is omitted from consideration. These biases can have significant implications affecting technology's fairness, accuracy, and trustworthiness. So today we're going to explore various types of bias in artificial intelligence, including sample bias, label bias, model pipeline bias, application bias, definitional bias, and survivorship bias. We're also going to discuss the importance of addressing these biases to ensure more equitable technological solutions. The first bias that we're going to talk about is called sample bias. Sample bias occurs when the data used to train an AI model does not represent the broader population or is based on historical data that inherently carries biases. For example, if an AI model is trained predominantly on data from a specific demographic group, it may not perform well when that data or the results of that data is exposed to a much more diverse group. This lack of representation can lead to skewed outcomes. It can perpetuate existing inequalities and it can unfairly disadvantage certain groups. It's important to ensure that a diverse and representative data set is integrated to avoid sample bias and to promote fairness in AI applications. This can also happen if the sample used is not the right size. If a sample is used that is too small, it will not accurately represent the much larger, broader population. You can see this a lot when you're looking at polling. A lot of times, only a certain number of people will be polled, 100 to 1,000, and the opinions or results from that poll are then applied to the broader population, which leads inherently to a biased perspective of the results of those polls because the sample size is simply too small. The next bias that we're going to talk about is label bias. Label bias arises when the terms or labels used to define the data are biased. So this can occur if the labels reflect stereotypes or cultural assumptions that are not universally applicable. For instance, the resulting predictions will be inherently biased if an AI model categorizes job applicants based on labels that are biased, suggesting that certain genders or ethnicities are better suited for specific roles. Label bias embeds societal prejudices directly into the data, making it challenging to detect and correct. To mitigate label bias, it is essential to critically assess the terms and labels used in data classification and ensure they are free from stereotypes and cultural biases. So imagine an Excel spreadsheet that has data across multiple columns and multiple rows. The way those rows are labeled or those columns are headed is label bias. And so that's hidden within the data set and can impact the results of the data and lead to bias that's not necessarily easily visible. The next bias is model pipeline bias. Model pipeline bias refers to flaws in the design of the machine learning model itself. A notable example of this type of bias is the Google Gemini model. It was originally designed to focus on diversity. So while the intention of the model pipeline was to create a more inclusive model, the emphasis on diversity, it failed to have sufficient regard for accuracy. So this led to a model that was biased in that it represented diversity over historically accurate, or I should say historical accuracy. And so this resulted in the rendering of historically inaccurate images in favor of diversity. So even though the model pipeline was developed with well-intentioned efforts, i.e. creating a more diverse image, it resulted in biased outcomes because the model design did not adequately account for all relevant factors. It is crucial that we design our models and our model pipelines that balance inclusivity and accuracy in order to mitigate pipeline bias. And this will then help ensure fair and representative outcomes. The next bias is application bias. Application bias occurs when patterns in data evolve, but the machine learning model is not updated accordingly. If a model continues to rely on outdated data, it will produce biased results. Additionally, how the application results are used can introduce further biases. For example, an AI system that monitors employee productivity based on outdated definitions of productive behavior may unfairly penalize employees who do not conform to those obsolete standards. Regularly updating models and critically assessing how their outputs are critically assessing how their outputs are applied is essential to reducing application bias. So it's important to look at the data, the labeling, the pipeline, and then the application. None of these work within a vacuum. They all impact one another. And through compounding, what could be a simple, bias that's built into the system gets compounded with each layer that's added to the data. Next is definitional bias. Bias in AI can extend to how terms are defined and information is classified. This issue is particularly prominent when dealing with subjective concepts where the definitions can vary widely based on cultural, legal, and personal interpretations. For example, hate speech is inherently subjective and interpreted differently across various contexts. To avoid biased classifications, an AI model attempting to identify hate speech must have a clear, objective, and universally accepted definition. Without such a definition, the AI may produce biased results, unfairly flagging or ignoring content based on an incomplete or incorrect understanding of the term. Another example of definitional bias is the classification of statements as true, false, or inconclusive. For example, an AI app analyzing a political debate classified future statements made by President Biden as true. This is problematic because it is impossible to label future events as true or false without misleading users. Predictive statements by nature are uncertain until they occur, and labeling them otherwise can bias perceptions and create confusion. Additionally, adjectives or descriptive terms like exorbitant are inherently subjective and can vary significantly between individuals, governments, and other entities. Marking subjective statements as true or false without acknowledging their variability suggests a bias that could misinform users. The next bias is survivorship bias. So, seeing beyond. Survivorship bias is another critical but often overlooked form of bias in data analysis. It occurs when we focus only on the successes or survivors and ignore those who did not make it, leading to a skewed perception of reality. This bias can cause misguided strategies as decisions are based on a partial data view. A historical example that illustrates survivorship bias comes from World War II, where the Allied forces initially planned to reinforce parts of fighter planes riddled with bullet holes from battles. However, statistician Abraham Wald pointed out that the aircraft that returned with bullet holes were the ones that survived. The real concern should be the planes that were hit in parts that caused them not to return. This insight was pivotal, highlighting the importance of considering what is missing in the data rather than focusing only on what is present. In AI and data-driven technologies, survivorship bias reminds us to seek out what is not immediately apparent in our data sets. We must recognize that the obvious is not the whole story, and we need to consider both failures and successes to see the complete picture. Remember, a failure is not a failure. A failure in emerging technology is an opportunity to learn and apply something differently. Without this comprehensive view, we risk making decisions based on incomplete information, and this in itself can perpetuate biases and lead to ineffective or harmful outcomes. Addressing bias in AI and other data-reliant technologies is complex, but it's necessary. By understanding the various types of bias, sample bias, label bias, model pipeline bias, application bias, definitional bias, and survivorship bias, we can develop strategies to mitigate these biases and create more equitable technologies. I hope by reviewing and explaining each type of bias, you can see how they're interconnected and relate to one another, that each one in and of itself must be addressed not only individually, but also collaboratively. Ensuring diverse and representative data, critically assessing terms and labels, designing models with accuracy and fairness in mind, regularly updating models, and clearly defining subjective terms while also considering what is missing are all essential steps in the artificial intelligence and emerging technologies processes. As professionals in this field, we must remain vigilant and proactive in identifying and mitigating biases in all of its forms. By fostering a more inclusive approach to data collection, model design, and application, we can work towards developing tools and technology that enhance our lives without continuing to perpetuate existing biases. This ongoing effort is going to be essential in harnessing the full potential of AI while minimizing the risk of perpetuating existing biases or creating new ones. We can build a more fair and equitable technological landscape for everyone if we all pay attention to each of these biases in each step of the process. I hope you found this helpful and beneficial. I hope that it explains all of the different biases and how you can be much more aware of them and discuss them as you are looking at integrating emerging technologies into your corporate environment. If you have any questions, be sure to put them in the comments below. I hope you like this video, and hopefully I will be able to see you and you able to see me in our next video. Thanks for joining, and I look forward to seeing you next time on AI. Let's talk about it.